Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is add minimum characters. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement. Pretty simple and straightforward. It says that you're given a string str and you have to find the minimum characters to be added at the front of string, okay, to make it a palindrome. Okay, so what is a palindrome? A palindrome is a string which reads same as backwards as from the forward. So I'm going to write a string. So now you can see that doesn't matter whether I read this string from left to right or from the right to left, the string will be same. Okay, now one example is given here. Let me explain the example. So we are given a string and string is ABCD and we have to add some characters on the front in order to make it a palindrome. Okay, so in order to make it palindrome, I will prefer to since I want the same characters at the front and last at each point, okay, for each index like I and j. So I will add this d to front, I will add this c to front, and I will add this b to front. This way I am sure that I will have a palindrome, and you can even see that I have DCBA BCD. This is a palindrome string, so I can return 3 as my answer. So 3 is going to be the output in this case. Now I hope you guys are clear with the problem statement. Let me talk about the solution now. Okay, so I'll start with the intuition first. Okay, now the problem that is given to us is I'm going to take an example, same example which was given to us like ABCD. Okay, and we know that for a palindrome string, the character at front and last should be equal for every I equal to j. Okay, so the first idea that comes to my mind is I can add the same character which is at the last to front in order to make a palindrome. Okay, so let me do this. If there is D, I will add D at the front, or even let me start from this point. If I have B, so I will add B at the front. Now this is palindrome. Similarly, I will add C at the front. This is palindrome. Similarly, I will add D at the front. So now again this whole is a palindrome. So okay, I can derive one observation from this point, that if we have a string of length n like this, so we can add n minus 1 characters in order to make it a palindrome. So minimum characters is going to be n minus 1. Okay, now I'm going to ask you one more question. Like I'm going to give you one more string. So if I have a string like, okay, so if I have a string like LAL and I have MN. For this string, can you please tell me what is the minimum number of character? So you will say, okay, it's fine. Like I will add n minus 1 character at the front and it will become palindrome. And even you're right. If I write mn, so yes, you're right that this is a palindrome. But the answer is wrong because this is not the minimum number of characters. Like if you say 4 is going to be the minimum number of characters, then this is not the minimum number of character possible, although this is a palindrome. So in order to have minimum number of characters, let's see what we can do. For this mn, I know that LAL is already a palindrome and I have mn as the remaining. So if I add this m to front and this n to front again, then I will again have a palindrome. Why this is a palindrome? Because I know that if I have a palindromic string in the middle and I keep adding equal characters at the front, like if I have P here and I add B and B here, so this is again going to be equal. If I add C and C here, this is again going to be palindrome. D and D again going to palindrome. So doesn't matter what is the length of this part, until this part is palindrome, so this whole string is going to be palindrome, and this is what we are using here. So I can write one observation which is going to be a final observation. Like if I have a string like uh, AB, AB, A, M, N, O. Okay, so for any string, I'm going to take this string. I will find the maximum, like the longest palindrome from the start. So you can see that this is the longest palindrome from the start. So I'm going to add this character to the front, and when I do so, then this will automatically come to the middle of this string. And now since the middle part is palindrome, so this whole is going to be palindrome. So I can write this observation as find the, okay, so like just find the minimum, okay, my bad, just find the maximum of maximum palindrome from the start, and after that we can simply return length minus start, isn't it? Like length minus whatever is the length of palindrome, let's call it L. So this is what we can do. Okay, now this is the intuition behind the solution, but the question you are going to ask is how to find the longest palindrome from the start. So now question is finding longest palindrome from the start. Okay, so this is what we are going to achieve now. Okay, so again there are two approaches to do this. The first approach is the naive approach. And this is the first approach that comes to my mind. Like what I can do is if I have a string, like I have a b b a and I have st. Okay, for this string, since like I can iterate for each character in the string, and for each character I will check whether the string from 0 to I is palindrome or not. So like if I'm at this position I, so I will check whether this whole is palindrome or not, and if am at this position, so I will check for this. So this is what I will do. So the pseudocode will look something like let me write the pseudocode. So I will check for I equal to 0 and I smaller than n. What I'll do is I will check if palindrome what s dot substring from 0 to I, right? This is what we can do, and after that if we have a palindrome, then our length is going to be equal to I, right? And we will keep iterating until we have find the longest length possible. Okay, and when we have the longest length, then we can simply return n minus length, where n is going to be the length of this whole string. Okay, so this is what we can do. This is the simple approach. Like you have you just need to write the is palindrome function. Okay, so now this approach talking about the time complexity, so O of n square is going to be the time complexity of this approach. Okay, and now if you write this approach, then this is not going to be accepted for C++ compiler. It's getting accepted for Java compiler, but it's not getting for accepted for the C++ compiler. So we can do some optimization, like we can use the two pointer approach. So this is a part of naive approach. So we can write two pointers. Okay, and how we can use two pointers? If I have a b b a b a, so I'll start from this point. Okay, and now I will have I at g point, this point, and j at this point. Okay, so while my I is smaller than j, while my I smaller than j, then what I can do is if my character at I position is double equal to character at j position, in that case I'll simply do I plus plus and j minus minus. This was simple, right? This is how we check palindrome. Like initially I'm letting let me tell you, initially I'm supposing that string from 0 to this position is my palindrome string. So that's why I'm taking my initial value of length as equal to n minus 1. Okay, so let's see whether I'm right or not. So I will check for this two. After that I will come here. After that I will check for these two. Okay, it is again. So I will do I plus plus j minus. After that I will check for these two. These are not equal. So what if not equal? What if not equal? When these are not equal, then I have to move I to here again. Like I will move my I to 0 again. Okay, and whatever the wrong assumption that I have made, I have to change this assumption. So now I will assume that okay, this is not the palindrome length, so this may be the palindrome's length. So I am going to change my length to length minus minus. So I will do something like length minus minus, and I will initialize my j with this position, and I will do again the same task. So I will do j equal to length. This is what I'm going to do. Now although it looks like I'm using the two pointer approach and it is an O of n approach, but unfortunately this is again the O of n square approach, because each time I'm moving my I to 0 again and again. Okay, now these are the like this is the part of naive approach that we have. So but we can do the same thing using the optimal approach. Let's see how. Okay, so optimal approach is going to be based on longest prefix suffix, and this is really going to be interesting as well as a bit complicated, but I want you to stay tuned. So let me explain this. If I have a string like a b a m, okay, so this is the normal string str. Let me write the same string in reverse order. So I will write reverse order as like I have m a b a. Okay, now for this string, if I write all the prefixes, so let me write the prefixes. The first prefix for this is a, after that I have ab, after that I have aba, after that I have abam. But what I'm going to do is m, okay, so let me write even abam. Now these are the prefixes, but these are not proper prefix. A proper prefix or suffix is a prefix in which we don't include the whole string. So I'm going to consider only proper prefixes. So proper prefixes. Okay, now what about the suffixes? So if I write the suffixes, I'm again going to write the proper suffix. So I will write a first. Okay, after that I will write ba. After that I will write this aba. Okay, this is enough. Now you can see that this prefix and this suffix is equal. So for this, like for this part, doesn't matter. This is indirectly. Just see what this particular thing indirectly means. This indirectly means that first of all, I am reading this a from the left to right. Okay, and here since this is the reverse order of this particular thing, so it looks like I'm reading from left right, like left to right, but actually I'm reading this string from right to left because m is here in this case. So it's like I'm reading this particular case like from right to left. Okay, so now I can see that from the first index, like for this part, from the first index, doesn't matter whether I read this particular area from left to right or right to left, it is same. Okay, so it is going to be the longest prefix suffix. It is the longest prefix suffix for this particular index. Now let me explain you this in detail. So indirectly this ABA is giving me the longest palindrome from the start, isn't it? So let me write this. This is giving me like longest, or I write ABA is the like longest palindrome from the like z index 0, palindrome from the start, like I from I equals to 0, isn't it? So and this is what we want. Our goal is, if you see the intuition, then you will notice that our goal was to find the longest palindrome from the start. So this is what we are going to, we can achieve like this longest prefix suffix. I hope it's clear to you. Like if I have the string in str and the reverse order, so even I let me write this in like another form. So initially I have like a b a m and the reverse order is m a b a. So I'm going to merge them. So I have a b a m a b a. So if I write the longest prefix suffix for this, then this is going to give me the longest palindrome from the like left from the start. How? Because this is what I am reading from left to right, and this part is what I am reading from right to left. So and this is what a palindrome means. So if these are equal, and longest palindrome, longest prefix suffix is what? Like I have longest prefix suffix. This is equal to longest prefix which is also a suffix, which is equal to suffix. This is what I'm going to calculate. So okay, this means that for this string I can add, like I can calculate the longest prefix suffix for the last element, and then that particular case is going to give me the longest palindrome from the start. Okay, let me write this observation. We can like calculate longest prefix suffix for last element, okay, or last index will be better. So last index, and this will give the, us the answer. Last index for modified string. Why I'm writing the modified string? Because you can see that now I have merged the like main string and the reverse string together. Okay, fine. Now I'm going to take an example. Like if I take the example is I have a string as a. So when I convert this string to modified string, then I will have a, and again I will have a. For this string, you will find that if I'm at this position, then this particular like this particular is the suffix, so and this is the prefix. So the longest prefix suffix is going to be of length 7 here, and we have the string of length 4. So what is the maximum length of longest palindrome for this string from the start? It is 4, but here I am having 7 as my answer, so this is giving wrong answer. So the reason it is giving wrong answer, because it is overlapping here, but we don't want this to overlap, like we don't these two string to be a separated string. Okay, so how to handle this? In order to handle this, I will simply put some character in the middle, like so I'm going to put a dollar sign. So let me put a dollar sign. Okay, and after that I'll simply write the same string in reverse order. So now you can see that in order to convert the into the modified string, we have to add a dollar sign or any character in between in order to avoid such conditions, like when there is overlapping of characters. Okay, fine. Now I hope the intuition behind the LPS is clear to you. Now I am going to tell you how to calculate LPS, because till now we have figured out something very interesting, that find the LPS of last index, right? And we have string as str. After that I have one like dollar sign. After that I have reverse str. So this is my modified string. So I'll write modified string, right? Okay, and now I'm going to tell you how to calculate the LPS for a particular string. So I have like a string. Okay, so let me write a string which is a and b. Okay, I'm going to take this string. Now one thing that we know is okay, it may be possible that you don't know, but I'm going to tell you that what about LPS of 0. Okay, so before starting with the LPS, I will say that in order to find the LPS of last index, I have to make a LPS array. Now you may question that why am making a whole array just to find the LPS of last index. The reason is, at every point, like at any point, the answer to this particular like index depends on the answer to previous indices that we have. So that's why in order to like avoid recalculation, I'm just going to use an LPS array. Okay, so you will get the intuition later. Let me first tell you what we have to do. Okay, so what we are going to do is, I'll start with LPS of 0. So LPS of 0 is always going to be 0. What is the reason? What is the reason? If I have a string, okay, so before that, before talking about this, let me talk about a string. A string is going to be L. I have a string of length 1. So what is the longest prefix suffix for this? This is my question. What you will say? You will say, for this L, I have the prefix as L and I have the suffix as L. So longest prefix suffix is going to be 1. But I will say this is false. Why this is false? Whenever we talk about longest prefix suffix, then I have already told you that we only talk about the proper prefixes and suffixes. Proper prefix and suffix. So the whole string itself is not a proper prefix or suffix. So whenever we have a string of length 1, then the like LPS of that string is going to be equal to 0. Okay, now I hope this is clear to you. So I'm going to make a LPS array for this. So I will have an array which is having length 4, 1, 2, 3, 4, and each LPS I. So let me erase this in order to avoid confusion. Okay, so LPS I is going to give me LPS from 0 to I, like LPS of string from 0 to I. Okay, which means that if I'm at this position, then LPS of I will give me LPS of this particular string. Okay, so if I'm at this position, then of course I have a string of length 1, so this is going to be always 0. Like LPS of 0 is always 0. This is what I was trying to tell you, but okay, it's fine now. Now I will start with this index. So let me name the indices. So what I'll do is, I will start my j with this position which is equal to 1, and I with this position. I is basically denoting the length of LPS. So till now I have the length of LPS as 0. So I'm at this position. Now I will check if these characters are equal or not. So see, this character are not equal. But what if these character are equal? Like if I have a string like a, so in this case I can see that these character are equal. In that case I have to like store. In that case my LPS of I will become equal to 1. Why? Because I have prefix as a here and suffix as a here, so and these are equal, so that's why. But in this case my character are not equal. So if my characters are not equal, then I will do simply j plus plus, okay, and I will remain same. Okay, now for this I can see that my I and j character are equal, isn't it? Okay, so now since my I and j character are equal, so I'm going to increase my I and j. Okay, so I have made one observation. There is only two possibilities, like either character are equal, like if character I equal to character of j, or they are not equal else, isn't it? So there are only two possibilities. Okay, so let's discuss both the possibilities. I'm going to write a string again here, ab. Okay, so I was at this position, j and I. Now if my character are not equal, then you have seen that what I was doing, I was simply doing I. Okay, so I was simply doing j plus plus. Okay, and if my characters are equal, then in that case I have to increase the length. So length is going to increase. After that my LPS of j will be equal to the current length that I have. After that I will do j plus plus. These are simple steps, right? So I am increasing the index, like I have increased the index from this to this. This is this portion, and after that I have stored the LPS of this one. So LPS of this is again going to be 0, like for this case. And for this case again LPS will be 1. For this case LPS will be 1. Why? Because I can see that these characters are equal. Okay, so whenever these characters are equal, then in that case LPS is going to be equal to 1 and I is going to increase. So now my I will point to this index. Let me rewrite this. I will point to this index and j will increase, so j will come to this index, right? After that I will check these two are equal again. Okay, so I can simply say that ab and I'm at this position, these are again equal, so again my LPS of this part is going to be 2, right? And now you can verify that for this particular string LPS of last index is going to be this particular string. So I have the like I have AB and AB as equal prefix suffix. So that's why I'm doing this. Okay, now I'm going to take one more example. One more example is AB, A and A. For this example, you can see that when I'm at this position, then it will say that these characters are not equal. So I will do simply J plus plus and LPS of I will be equal to 0. Like LPS of j equal to 0 and then j plus plus. But is it right? Is it right? No, it is not right. Why it is not right? It is not right because it may be possible that I have this a or this proper prefix suffix as like before, as LPS as before, like before this y b. Even you can see that for this case my LPS is not equal to 0, like this a and this a are equal, so my LPS is 1 in this case, but it is returning 0. So how to handle this? We have to only do this operation when we have I equal to 0. But if my I is not equal to 0, then we have to do something else. And now I am going to write a line which is going to blow your mind, right? Like I will write here I is going to be LPS of I minus 1. Well, this is really something tricky to understand, but you can see that when I do LPS of I minus 1, then I will jump to this index, and for this index I can see that these are equal and it is going to give me 1. Okay, so this is the code for LPS. This is what we have to write. Even if you write this code, then it is going to get accepted, but the question you will ask is, what is the reason behind this? Why we are doing this? Okay, so let me explain this. This is the last part that I'm going to explain. After that my approach as intuition is clear. I will just show you the code. Okay, so suppose that we have a particular string, and till this part I have seen like the equal prefix and suffix, and I'm at this position now. This is my j and this is my I, right? This may be the case, and character at these position are not equal. Okay, so what to do in this case? This is what we have to find, right? In that like if you see the above scene, then this is the similar case. Like we have current character which are not equal. So this is what I'm going to explain. Okay, I'm not able to navigate in this, I don't know why, but okay. Now for this, I know that this particular prefix cannot be my answer, but it may be possible that I have some other prefix in the same string, like I have new possible prefix here which may be equal to this particular part, which may be equal to this, and in this case this prefix and this suffix will be equal, right? So I have to find this index. Let's call it index. My task is to find this index where I have to like move this I in order to have my next possible answer. Okay, so this is my next possible prefix and this is my next possible prefix. Why I am writing this as equal? Because since if my prefix and suffix are not like equal for this case, then I will have the same here. Okay, now I am going to tell you one more thing, that if this whole part is equal to this part, so this part is surely going to equal to this part. I hope it's clear to you. Okay, so it is again going to be NPP, like next possible prefix. So now what about this index? Like okay, so what about this particular index? This particular index is, if this is I, then this particular index is going to be I minus 1. Okay, now let me zoom this scenario. This scenario is saying that I have like I have prefix here and I have one suffix here. These two are equal, and this is my index, this is my index, and this is my I minus 1. So what is this value? If you see carefully, then you will notice that this value is nothing but LPS of I minus 1. Why LPS of I minus 1? Because this is, we can see that this prefix and this suffix is equal. So LPS of I minus 1 is going to be I in that case, right? So I have to return like LPS of I minus 1 is going to be equal to index, right? Because I have this prefix and this suffix as equal. Okay, and what about this index? This index is the next position where we have to move. So I will write I equal to LPS of I minus 1, right? So that's why we are doing LPS of I equal to I minus like I equal to LPS of I minus 1 in that case. Now I hope the code and approach is clear to you. I'm going to show you the code and you will understand everything just looking at the code. Okay, so this is the first approach that we have. I have not shown you the approach, but now I am going to show you, even because I have explained the code in the while explaining. That's why I have not shown you the code. This is the second approach. Okay, this is the main approach that we have. I will start from this position and I am forming my new modified string here. After that, I am finding my longest prefix suffix for last index. This is what I have to do. Okay, and this is what I am going to do at last. Now I am going to show you the code to find the longest prefix suffix. So this is the code. This is the code to write find the longest prefix suffix. Let me expand it here as well. You can see that the code is very similar to the one I have explained you. LPS of 0 is always going to be equal to 0. I is 1, and okay, here instead of j and I have taken the length and I. Okay, but you can take j and I as well, doesn't matter what you take. These are just variables. Okay, but the concept should be clear to you. So here I am checking the same condition, but like if character are equal, then I'm going to length plus plus. Okay, that's why I have taken this as length instead of I, because this is going to give me the length of longest prefix suffix till the current point. Okay, and you can see that this is what I have explained you, and this is quite simple, right? If my length is equal to 0, then I can't do something like length minus 1. So that's why I will simply do length of I plus plus equal to 0. Okay, after that, this is what I have to return, like I have to return the LPS of last index. So now this is the same code on the right hand side, which is C++ code. Now I hope everything is clear to you related to this question. I have explained two interesting approaches to solve this problem. So this is all about this problem. Thank you.